we now always use a big farmer's tractor to put up and down, which is slightly more costly, but it's a lot easier. Because we do the putting up and down ourselves. The output's similar to the Proben, but hang on, I'm just going to go back one there. The interesting thing there is having the two up right side by side. We published the data on our website, and when Iskras went up, being new into the market, they were very keen to show that their new design was more efficient, better than the Probens. And unfortunately, we're looking at the data over about a year, the output from the Proben was about 5% more than the Iskra. And we got this phone call from Iskra. Could we fit our new blades? We've redesigned the blades over the last year, and we think it will improve the performance no end. Yeah, of course you can say. Hey, come on, winch it down, new blades on, winch it back up again, monitor it for a year. You can see the data on our website. Fantastic, the output's gone up by about 10%, so they're now 5% more than the Proben. Get a phone call from Proben. Can we come and fit new blades? Our latest blades are much better than the old ones, I'm sure it'll improve the performance. Okay, yeah, go on. They came with fitted new blades, and we winch it all back up again and monitor it for a year, and the Proben is now about 8% more than the Iskra. So interesting how blade design can change things. So that's really good. They're both improving their performance. Iskra a bit miffed. On paper, theirs produces more. They cannot figure it out. Power curves, da-di-da, computer model. What is going on? So another phone call. Can we come and fit an anemometer which measures the wind speed on each tower at the same height? They've done that, and we've been monitoring for about 4 months. And it turns out the wind speed at the Proben site is about 40% higher than at the Iskra site, even though they're only 30 metres apart. And it's due to the line of trees about 100 metres away is causing that significant difference in the wind speed. And that difference means actually the Iskra is more efficient, because if it was in the same slightly higher wind speed as the Proben, it would be producing more than the Proben. So the story continues, basically. But it's interesting. So there's a slide of, it's actually before we put up the Iskra, but you can see the Proben in the background there, and that's our roof. The back of the houses are earth sheltered. The front is a conservatory, which you can't quite see around the corner there. So we didn't have very big a space to put photovoltaic panels, and we took advantage of the Clear Skies grant programme to put these up, because faced with the same conundrum really, they just cost a lot of money. Great technology, no moving parts, easy to install, no noise, fantastic, but it costs you. And it is a capital cost which is high. So this is us installing them. They're installed in a long line along the top of the roof. You can just see the conservatories on the front of the houses there. And these boxes are just filled with stone to weigh them down, so there's no fixings through the roof to make holes in our roof, which I was quite keen about. And you just bolt the panel on top with 4 bolts very quickly in and plug them together with the wire. It's a very simple, quick installation. And you could do that, in a field or in a garden if you wanted to. This is us delivering up the back of the roof. Now this is quite unusual. You don't often get the chance to drive your tractor up your own roof to deliver your photovoltaic panels to have them right there. So I just thought that was quite an amusing slide. And then inside you do need an extra little kit, which is this. This is one of those inverters I was talking about. Exactly the same for the wind turbine or the PVs in our case there. This one's called a Sunny Boy. It's made by SMA, a German company. And that's the electronics that takes the output from the photovoltaic panels and converts it up to 50 hertz and grid voltage and so on. And so it's no fun. You just got 3 little lights, tells you whether it's working or not, and it just sits there working away. In some ways that's not so good, because you can't actually see what's going on unless you monitor it yourself, and we have found without the monitoring, without the observation of what it's actually producing, you can find they're not working as well as you thought. There's quite a lot, I think, of monitoring specifically on what your renewables are producing. And to give you an example of that, when we harmonised with Europe in the mains voltage, we did have 240, and we've been harmonised to 230. But to do that, they didn't actually change from 240 to 230. They said, well, we'll have 230, but we'll have plus or minus a bit more, so we can still produce at 240. But when they did plus or minus on the 230, it expanded the range slightly differently to the 240 range, because there was a plus or minus on that. And when those inverters are detecting a grid that isn't quite within specification, they turn off the panels. That's a safety feature, because usually when the grid goes down, some electrician has to go and bolt the wires back together and go and electrocute you with your electricity, so they have to turn off when there's power failure. And they consider a power failure to be the grid slightly out of spec. So when we converted to European voltages, the spec changed, so our inverters kept on turning off. Sometimes, not all the time, but sometimes we lost about 10%. But had we not been monitoring them, we wouldn't have known they were down 10%. Because you can't, tell whether it's coming on 10% earlier than it should have done before. And the trouble was there was no information flow. Nobody told us that the grid voltage, it wasn't until we dug into why has it gone down 10%? Well, it's because it keeps on turning off. Why does it keep on turning off? Well, because the voltage is wrong. Why is the voltage wrong? Well, that's because the grid specifications changed. Okay, so we'll get somebody in to change the specification in the inverters and put them right, so we get up. Now, there's no information flow there at the moment. Who's telling who? All these 750,000 renewable energy generators that something's changed, which is going to affect your output. Who knows? If you're not monitoring it. So monitoring is very important. What's their impact? Much easier to get planning permission for, although I think visually they have quite a significant impact, but in a good way, of course. But nevertheless, seen as less of an impact by planners and much easier to put up. Now you can see around the front of our houses, we're facing south, so the sun's coming this way onto the houses and the photovoltaic panels running along the front, and I think they sort of fitted in quite neatly, I suppose, into the design of the houses as they stand there. This is a graph of the output from the various generators we've got. So the red bars are from the photovoltaic panels, and you can see they're more, this is months of the year on here, and it's kilowatt hours per month up here. So we've got more in the summer from the PVs, and the blue and the green from the wind turbines, and we've got less in the summer. And then neatly the other way around, so less sunshine in the winter, surprise, surprise, and more wind in the winter. So they neatly balance each other out as the systems go. The other element of the system, this is a diagram of our hot water tank, because you can't see that, it's buried basically, but heat pump supplying hot water goes into the tank and out again. But what you've got to recognise from here, the critical bit about this diagram is the thickness of the insulation. That insulation, a typical house might use 12 kilowatt hours a day of hot water. We use only 4. And the reason for the reduction is not the heat pump. The reason for the reduction is 250 ml of insulation around the hot water tank. And that particular design of hot water tank, which is a very high volume tank. So most of your saving, as ever, is from conservation. Properly insulated the tank, you reduce it from 12 to 4. That's most of your benefit, to be honest. Then the last 4, right, okay, where does that come from? So we'll install a heat pump to generate that 4 kilowatt hours a day, back up the merchant heater.